So on the whiteboard here, the y-axis is usually representing the result of a change. The x-axis is what we change, like, so the change itself and then the result of the change. And then the slope is often denoted by like a rate or a change in something. And then the y-intercept is an initial value. So when you ever see like start or begin or initially, whenever you see those words, they are usually the y-intercept. And then change in x is so what what we change during the experiment, and change in y, yeah, that's the result. And then the x-intercept is, so when the measurement reaches a value of 0, that's the x-intercept. So you don't see this quite often, but you see it from time to time. And so kind of refresh on your memory. And then last time we worked through an example. So how fast, that's the speed, which is a rate of moving. So that is the slope. So you just find the slope. And that's how you find the speed usually from a graph. And then the second question was, how high above sea level is Jerusalem at the starting point? So starting point, that's your key here. And so that's the y-intercept. And then the last thing we talked about was putting an equation to the line. So what is the purpose of putting an equation to a line? Well, it's so that for any given time, we can find exactly what the y value is. So actually, let me use this graph over here. So by finding an equation like this, so it can be in intercept form or not, whatever. But if you have an equation, then for any given value x, you can find the y value. So if I have an equation and I want to know what the y value is at this point, then with an equation, I can find it out what this is. Or like, say, I want what the y value is at this point. So if I have the equation, I would be able to figure this out. So, oh, what happened? Why is this rainbow? No. Somehow they switched the whiteboard. That's why it's so... Oh, that's what... Okay. Yeah. So if you want the y value at this point, with an equation, you can solve for it. Okay, let me delete that. I don't want that. How do I change it? Nope. Very sorry about this, but I don't know what happened. Oh, yeah. What? Why is it becoming an arrow? Oh, do I have to use this? Yeah, okay. That's so weird. Anyway, so let's move on to another example. Maybe I'll do this one since it's been a long time, and I'll refresh you on some of this. Oh yeah. Can't even move now. Okay. This is not very convenient. Okay, so I have the question here. So this is somebody, he grows a beard, and then so if you don't shave your beard just keeps growing. So that's what this represents. So as the time passes, his beard length increases. So it's in millimeters. So essentially, well, the first question is, how fast did Rip Winkle, yeah, that's his name, I guess. How fast did it grow? So right off the top, fast, how fast? So that's a weight of some sort. This is way too thick. See if this is better. Yeah, that's better. So this is a weight of some sort. So that's a bit too small. So if you want the weight, all you got to do is to find the slope of this line, because so usually the weight represents a slope. So let's find two good points. I think this is a good point over here. So this point and this point, I'll find the slope using these 2 points. So slope again is the change in y divided by the change in x. So weight equals to so if I pick these 2 points, so again, right, with the slope, if it's a straight line, it doesn't matter where I pick the points. The slope is the same everywhere. So here the change in y is 60 minus 10. So, and the units are kind of important in web problems. So I would include the units. 60 millimeters minus 10 millimeters divided by the change in x is 20 weeks minus 0 weeks. So this is 0 over here. So this simplifies down to 15 millimeters divided by 20 weeks. And you can simplify this down even more. And this is equal to 5. So if I divide 10, top and bottom, I get 5. So it grows 5 millimeters every 2 weeks. This is what the slope represents. So because this is asking for how fast did the beard grow, so that means when you get an answer, what this represents is that for every 5 weeks, no, for every 2 weeks, my bad. So for every 2 weeks, the beard grows 5 millimeters. So there you go. So in fact, you can, if this might not be so intuitive, you can even simplify it down even more, which becomes 2.5 millimeters every week. And maybe this notation would be even better, depending on how you understand the topic. Because, so in this case, these are the same thing, but essentially I'm saying that for every week now, it grows 2.5 millimeters. So it represents how fast the beard grows, so that is the slope. And then again, the other question we can ask is, what is the initial length of his beard. So the key here is initial length. So as I was saying previously, that represents a y-intercept. So it's pretty clear what it is here. It's 10 millimeters. So as simple as that. 10 millimeters. And again, right? Like initial, when you talk about the initial length, that's just like in the beginning. So in the beginning, no time has passed. Like it's just at the beginning, time is equal to 0. So at time 0, the y value is a special y value called the y-intercept. That is why it's the y-intercept. It's just 10. Or like if you don't look at this as a y-intercept, it's totally fine as well. You just look at the x value, which is 0, then the y value that it represents is just the answer, which is 10 in this case, 10 millimeters. And then with these information, we would like to come up with an equation. So here. So we want an equation that represents the relationship between the length of beard and time. So again, why do we have to do that? Or why do we want to do that? You don't have to do it. It's because if you, so these 2 points are pretty simple. At time 0, the length is 10. Or at time 20 weeks, the beard is 60. But what if I want to ask you, what is the length of his beard when it is, say, 27 weeks? The 27 weeks would be somewhere around here. Not quite at the straight line part, but like somewhere around here. How do you figure out the length of his beard? You cannot really, looking at the graph, because the increments are not by 1, so can't really figure that out from this graph. So what will help you to find it is using an equation. So first, let's come up with the equation. So usually with these these graphs, looking at the graph and coming up with equations, all you need is a slope-intercept form. Is sufficient enough. You don't need all the point slope form or standard form or whatever. All you need is a y-intercept form, slope-intercept form. So y is the result. We talk about y, the dependent variable, as a result, and the result is the beard length. So yeah, maybe let me color code this. So y, and then m is green for x, and then maybe orange, yellow for the b. So y is the result. So by changing the time, what the result is the beard length has changed. So y is equal to the beard length. And then what the m is the slope. So slope is a rate of some sort. So we found that out as how fast the beard grows. And then x, so it is the independent variable, and this is time. And b is the y-intercept, so that is the initial value. So we in fact have all these data from the last two questions. So we have how fast it is, and we have the y-intercept. And we don't really need a value for y and x. That is changing, right? So y, the slope, as we found out, was 5/2. X is just x. And then plus b, the y-intercept, was 10 millimeters. So that's all you do. That's your equation. So how is this helpful? So here's my question. What is the length of his beard at, let's say, 26.8 weeks? So there's no way of knowing that just simply looking at the graph. You won't even know where 26.8 is. I don't know where 26.8 is. But with this graph over here, with this equation over here, we know that this represents a relationship between the time, so x is time, versus the length of his beard, right? So the length of his beard is essentially when x is equal to 26.8. So at 26.8, x is equal to 26.8, you solve for this, you get y. So let me put this in. So y is equal to 5/2. I forgot the calculator again. But yeah, let me do this. Come on, get out. Okay, so the length of his beard, again, red represent the length of his beard at 26.8 weeks. And then we just got to add the 10. The 10 is the constant. It doesn't changes. So as long as you calculate this, you get the length of his beard. And this value here comes out to be, so it's not a nice number, so I will use a calculator. It's okay to use a calculator. So 5 times 26. Oh, it's actually pretty nice. 77, and the unit is millimeters. That's the entire question is in millimeters and weeks. So the length of his beard, simply plugging the numbers in. 26.8 weeks, and then add 10. So comes out that it's 77 millimeters. So that's essentially all for one question. But just to recap, when we talk about, so the initially was how fast, so that's a weight. For weight, you find the slope, and it was 5 millimeters per 2 weeks. And then we talked about the initial length, so that's an initial value, is the y-intercept, so that's 10 millimeters, just seen directly from the graph. And then we come up with an equation that represents the relationship between the length of beard and time. And often we only need the y-intercept form slope intercept, I mean. Yeah, and then, so y is the dependent variable representing the beard length, and then m is the slope, so how fast the beard grows, and x is the time, change in time, and b is the initial value. So with the 5/2 and 10 that we calculated from the previous questions, we got the equation. And with the equation, we can find the length of beard at any time. So 26.8, 35.5, you plug in 35.5, 2.1, you put in 2.1, and then you will be able to get the length of his beard. So that's all. And you can actually do this the other way around as well. Here, I'll ask you this now then. So using this, I plug in the x value, but what about this? What time is the length of his beard? 50 millimeters. So that's my question to you. So before you get started, let me just go back to here, the graph. So if, oh, so at 50 millimeters, so at this this point over here. So at some certain time, so we actually don't know what the time is here, but at a certain time, the beard is at 50 millimeters, and I want you to find this time for me. So that is what the question is about. Essentially, at this point, what is the time? So you cannot really tell from looking at the graph, but as I was talking about, right, that's why the equation is helpful. So there's my equation. So what is the, at what time is the length of the beard 50 millimeters? So let you give it a try. 2 minutes. Oh, Chloe, you're private messaging me. So I just saw. Yeah, yeah, I'm speaking right now. So, yep, X is, so Chloe says X is 16. So at 16 weeks. So anyone else with a different answer maybe? Or the same answer? Wait, no? Still can't hear me? It's my How about now? Do you hear me? Can everyone else hear me? Okay. On my side, the audio seems like it's working. So, okay. Nobel, what do you think the answer is? James? So, you got the same answer, then it's the same, say the same answer, but if you get a different answer, then say a different answer. What is it? No? Okay, I guess I'll go over this one first. You guys can do the next one. So Chloe is right. 16 is the correct answer. So, but like, just don't just write x is equal to 16 because so always when you have a word problem, it's always nice to include the units, so it allows the person to understand what it means. So because I let x be the week, so I said previously that x is the time, so technically it's all right. Like 16, I know it's time, but it's always a good idea to write down the units as well. So how we approach this, similar to the last one, but not exactly the same, is that at so we know the result, we just don't know what the time is now. So we just set the equation when y is equal to 50. And everything else is pretty similar. Solving for x, and then add the initial value is always there, no matter what you're solving for. Don't forget to include that. And now all you got to do is solve for the equation. Oh, let me change back to a black. So I could minus 10 on both sides, and then I get 40 is equal to 5 over 2x. And then to isolate the x, I would multiply both sides by 2 over 5. So the 2 over 5 times 5 over 2 cancels out to become 1. So I multiply this side by 2 over 5 as well. So I get, so cancel, 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 get x is equal to, and then 40 and the 5 can cancel to make 8, and 2 times 8 is just 16. So at 16 weeks, his beard is 50 millimeters. So there you go. That's your answer at 16 weeks. So essentially, it took him 16 weeks to grow 50 millimeters. That's another way you can think of it. Okay, any questions? Oh, that's okay. Yeah, your Wi-Fi died. That's okay. Are you back in now? Okay, so that's the first example. We can move on to another one. And then mostly you'll be doing this one now. So let me find this graph. This graph is a bit different. Although it's actually it's not that much different. God, I don't like this new setup. And it's not very convenient. Okay. So here's the problem. So the first question is, how far was Saint? So let me read out the question, I guess. So Saint is the person. He is exploring a volcano, and all of a sudden, so he went. So if this is the volcano, and then you can kind of see inside, I guess. Imagine you can see inside the volcano. He was exploring the volcano, and then he ended up here. He went down, and he's here now. So at this point, he hears some rumbling. So he decides to go up, climb out the volcano, get out as soon as possible before the volcano erupts, maybe. So, and then, so his elevation relative to the edge of the inside of the volcano. So elevation means the change in the height. So at 0, the elevation, so at the top over here, his elevation is 0. That's what it represents relative to the edge. So that means when he goes down, his elevation becomes negative. So as seen over here. So he climbs up, 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 and then he got to the top. So this doesn't mean he's going uh, diagonally. So it's not his path. This doesn't represent his path. This represents the change in elevation over time. So because it takes time for him to climb up, that's why it's kind of diagonal. But it's not like he's at this point and he climbs diagonally up. No, no, no. He is just climbing straight up. So imagine Zane is over here. He's just climbing straight up to the edge. But because it took time, that's why on the graph it looks like it's diagonal. But anyway, so that doesn't really matter as long as you know that the elevation is related to the time. So the first question is, how far was Zane from the edge of the volcano? So at the edge is at 0. When he started climbing. So I underlined the two important thing here. So what's the answer? Anyone? Anyone? So how far? We're talking about the elevation here. When he started climbing. Yep, Chloe. Chloe said negative 25. That is the correct answer. So negative 25 meters is the correct answer. At time 0, the y-intercept started climbing. That's the hint of y-intercept. And it's just negative 25 meters. Time 0, that's the elevation it represents. So second question. Let me change it up a bit. At what time did he, what happened? Reach the edge. So this is the second question. At what time did he reach the edge of the volcano? Here's the graph. So Chloe got it. Okay, 35 seconds. So when he reached the edge is 0 over here. So if you go all the way across, you can see that here at 35, that's when he was able to get up to 0. So it's just 35 seconds. So looking at the graph, goes up, 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 up. Takes time for him to go up. And then, he got it at 35 seconds. So 35 also represents the entire duration of his journey, essentially. And he essentially stopped over here as well. So from start to finish, it took him 35 seconds. And then, here now, how fast was Zane climbing? Oh no. So how fast was he climbing? So nowadays, I like to put a horizontal line across my Z. I didn't do that until like recently because like gets confused with a 2. So like if I say 2Z, that looks like 22. So I put a line across, then it's 2Z. But just something I do to make it less confusing. But the question is, so maybe Olivia, you answer it this time. How fast was he climbing? 35 divided by negative 22. So you want to, so the slope is the change in y over the change in x. That's always the slope. How fast it goes up by the time. But 35 is the time. Right now this is kind of like time over distance, time over elevation. 3 over 4. 3 over 4. Maybe you want to check your simplifying again? So I'm guessing you picked this point and this point. Wait, what happened? Did it freeze? Oh, sorry. So this point and this point, fair enough. Those are actually two really good points to pick because it's very obvious. So the change in elevation is 25, yeah. 25 meters, 35 seconds. But when you simplify this, I don't think this gives you 3 over 4 though. -7 over -5. So again, you are trying to have the elevation, so change in the distance over time. You don't usually say, like when you look at your uh, speedometer on your car, it doesn't say 30 like seconds per time. -5 over 7. Ooh, very close, but if you remember from way back, I talked about this as a positive slope, and this here is a negative slope. So if you have -5 over 7, it will look something like this. Right? Because what negative represents is that he's going down 5 meters for every 7 seconds. So yeah, it's just 5 over 7. So yes, the sign is, it can get kind of confusing. So how you want to avoid making these type of mistakes is instead of just picking up the values, what you do is you actually write out the final minus initial. So final is 0, the elevation, that's its final, minus the initial is -25. 0 minus -25. So the distance is final minus initial. The time must also be final minus initial. So the final time was 35 seconds. And then minus the initial time is 0 seconds. So 0 minus -25 is add 25. So this is 25. Oh, don't forget the units. Divided by 35 seconds. And when you simplify this down, it's not 3 over 4, it's 5 over 7. 5 meters for every 7 seconds. That's how fast he's going. And like I said, right, like by the sign, if you have a -5 over meters over 7 seconds, it means he's going down every 5 meters every 7 seconds, but that's not what is happening here. It's going up. So if you get a negative, that should be, so use your common sense to look at the graph, see if it makes sense. If it does, then most likely it's right, but if it's kind of sketchy, so negative, how is it going up, then you should probably check over your work again. So the correct answer is this. 5 meters for every 7 seconds. So now we got the y-intercept. So negative 25 meters is the y-intercept. And we have the slope. So guess what? Find an equation that represents represents the, oh no, Saint. He has a name. So Nobel, do this one. You haven't answered much today. So here's your task. Zoom out a bit. Find an equation that represents his elevation according to time. If you look at the graph, time is our independent variable and y is our dependent variable. And everyone else try it as well. See if nobody will be getting the right answer or not. So what is it, Nobel? You don't know. So equation, you don't really care about the form. So the simplest form, just y is equal to mx plus b. So that's the slope-intercept form, where y represents the result. So in the real problem, it's the dependent variable, and x is the independent variable. So those are the variables. You don't have to change anything about them. But m is the slope. So slope, as I said, was the rate, and b is the initial value, the y-intercept. So based on Excuse me. So based on what we found in the previous questions, so here, this one represents his initial position, right? And then this here is how fast he's climbing. So the how fast he's climbing is his rate, and the rate is the slope. The slope is the rate in the word problem. So we actually have all the numbers here. So all you got to do is put it together. So again, an equation, what it represents is the relationship between elevation and time. So we have the slope and we have the initial position. So what is it? So what is m here? What is this m? So m is the slope. Nobel, what is the m? So the slope is a rate, and the rate is, and this question is how fast, the speed. Speed is a rate. Just 5 meters? 5 meters is a distance, but we want a speed. So speed is distance over time. So m is the slope. Slope is how fast, so it's a rate. They're the same thing. Slope and rate is the same thing. So what is the slope equal to? I just want the slope first. It's not just 5. The slope is 5 meters per 7 seconds. That's the rate. That's how fast he's going. When you talk about how fast something is going, you don't just talk about the distance, right? Like, how fast are you going? I'm going 100 meters. That's your distance. That's your total distance. Or you don't say, I'm going 10 seconds. That's your time. How fast you're going is distance over time, like 100 kilometers per hour. That's what it represents. 100 kilometers, that's the distance. And then over 1 hour, that is the time. So distance over time. So your slope here, it's not just 5 or it's not just 7. The slope is 5 over 7. So how about the initial value? The initial value have nothing to do with the rate. It's a separate thing on its own. Like, if you look at this, he could have started here, and he went up like that. He could have started here and it went up like that. Doesn't matter. But it shows it right on the graph that his initial position, B here, is the y-intercept, and it is the initial position. As I was saying, that whenever you see something like initial or start or begin, that's an indication of a y-intercept because time is equal to 0. That's why it is a constant b. So b here, negative 25 meters. So when you combine everything together, essentially all that you just need to put in the numbers. So you got the, God, why is this? So yeah, this doesn't go away but on its own, which is annoying. So you got this 5/7, and x is the time plus negative 25, so I can just say minus 25. So this is the equation. And y is elevation. Y is the distance, elevation in meters. And x is time. Time is in seconds. This is the equation that represents his elevation in relationship with time. Does that make sense? Yeah, so you got it. Yeah. So with this equation, let me ask you different things then. Uh, when saying is at negative 10 meters, how long has he been running? Yeah, or climbing. Yeah, he's climbing. He's climbing upward. So I won't scroll up, but I will kind of sketch it out here for you. So here's negative 25, and he kind of went up. Oh, something like this. Oh, and then this is 35 seconds. It's negative 25 meters. And then essentially, when he's at negative 10 meters, so that's around maybe here, I guess. Negative 10 meters. How long has he been running? What is the time here? So that's the answer. That's the question. So, James, would you like to give this a try? It's your turn to answer a question today. You don't know. LOL. Okay, somebody else? Maybe? Olivia, how about you? You came in a bit late. You didn't see the last question, but you can do it, I think. Uh, uh, 5/7 minus 10. Is that your answer? So, at what time? How long has he been climbing? So, trying to figure out this number here at what time. So, could you maybe show me? So that comes out to be a negative answer. So time cannot be negative. You say 5/7 minus 10. That comes out negative 9.3, around negative 9.3 seconds, which is not possible. You can only have, time can only be positive. So maybe think that we call what this represents, right? It's the relationship between distance and time. So if you know the distance, you can solve for time. If you know the time, you can solve for distance. You know, when you plug in a number here, you only have one variable left, so you can solve for it. If you plug in a number here, again, you only have one variable left, and you can solve for it. So it's about plugging in numbers. So perhaps I can make this a bit clearer. This here is elevation, and this here is time. And in this question, you are given the elevation, so you need to solve for time. Yeah. So what is it, Olivia? Okay, yep, I think that is a good start. So solve for x then. So your equation is correct now, but I want a precise value. How long? That is correct. Question mark, question mark, question mark. Always. Yep. So how you go about solving this? Exactly like that. So negative 10. That is his that's his elevation at a certain time. and we're trying to solve for that certain time. Minus 25. So set up the equation, and I can add 25 on both sides. I will get 15 is equal to 5 over 7x, and then multiply both sides by 7 over 5. So these two can cancel out. 5 cancels with 5, 7 cancels with 7. You're left with x, and then 15 can cancel with the 5 to give 3. 7 times 3 is 21. So x is the time, right? It represents the time. So we say that he has been climbing for 21 seconds. So again, this is an equation. So if you have an equation, you can check whether your answer is correct. So let's check. So if 21 seconds is correct, and then I can plug in the 21 in here, the left side and the right side, they should be the same answer. So let's see if this is true. So cancel this. 21 divided by 7 is 3. 15 minus 25. And indeed, negative 10 is equal to negative 10. So this is how you can check if your 21 seconds is correct. If it is not correct, then the right side and the left side would not be equal. But if since when I plug in 21, both sides are equal, that means 21 is the correct answer. So he has been climbing for 21 seconds. So he climbs for 21 seconds, then he got to negative 10 meters. That is what this equation represents. Delete this. Okay, so that's that. I'll give you another one. Where is saying that when he has climbed for 32 seconds. So Chloe, answer this one. Chloe, idea? This is not a nice number, so you can just use a calculator. You can use a calculator. Negative 17 over 7. Let's see if you're correct. Solve. y. We're trying to solve for y now. So where is he at? That's an indication of elevation, not time anymore. So same equation, except now we're plugging in the x, which is 32. No, plus minus 25. So you gave me a fraction. Nice. I'll do it in the fraction as well. So 5 times 32, 160. Yeah, 160 over 7 minus 25 times 7 is 25 times 7. God, better work on my arithmetic. Oh, 175, that's right. Divided by 7. And indeed, you are correct. Excuse me. Negative 15 over 7 meters. So, word problems is okay if you don't leave it in the fraction form. You can just directly calculate this around 2.14, negative 2.14 meters. So after climbing for 32 seconds, Zane is 2.14 meters away from the edge. So he's almost at the edge. So if you go back to the original diagram, you can kind of see, right? So 35 is here, 30 is here, so 32 is somewhere around here. So if you climb for that long, so it's very close to this point over here. Not precisely, but even though I did draw on the line, it's not precisely there. So it's somewhere around here. And negative 5 is here, 0 is here, so negative 2.14, about right. So when you see the graph is also a good way to check your answer. We like to see things as humans, so it's always nice to see a picture. So that's all for this question. We know the time, so we solve for the elevation. Here's the third one. So where is saying and when he has climbed for so there's your question. Anyone can answer this one? Anyone? Okay. Yeah, that seems about right. 15 over 7. That simplified down to 15 over 7. So 8 minus 25. And you do all the simplifying stuff, you would indeed get to 15 over 7 meters, which is approximately 2.14 meters. Now, but here's the catch. This is a word problem. So when you have the word problem, you're not only dealing with an equation. An equation is a mathematical representation of something in the problem. But the however, if you look back at the problem here, he stopped at 35 seconds. So I asked that I asked where is he at 38 seconds, but he would not be climbing anymore actually. So that would be outside of, so this question, so he actually couldn't have climbed 38 seconds. So if he continued climbing, that would not be possible because the volcano is only this high. If he continued climbing, he'll be flying. He'll be flying up top. So that would essentially means that he's 2.14 meters on top of the volcano. So yes, mathematically this is correct. So if you're given this question and then is asking for this, then you would give this answer. But the actual answer should be that this is actually a wrong question. This question is incorrect. This question in itself does not make sense. So because he could not have climbed 38 seconds. He is already at the top of the volcano at 35 seconds. The higher he climbs, he can only fly, but that's not really possible to fly 2.4 meters, 2.14 meters up. So this question in itself is wrong. And that is because even though mathematically it makes sense, like you're given the equation, where's our equation? Here's our equation. You can plug in any numbers you want, but and then it will give you a legitimate answer. So as long as your calculation is correct, y would be right. It would fit this relationship. But with the word problem, it's not only the math anymore. You have to also think about if it's realistic or not. Like imagine if I say, uh, here's another question that would not be realistic. How long has Zane been climbing for when he is at negative 30 meters? So I'll just quickly do this. It doesn't matter like how you approach it. So that's not the point of the question. My point is, when you solve for this equation, so I'm again plugging in the equation. And then if I simplify this, I would get negative 7 is equal to x. So that's my answer. So don't worry too much about the steps if you are kind of confused. But essentially what I'm saying is that it's not possible to have negative 7 seconds. Like seconds time, as I said before, must be positive. So if you're asked this question, where is he at negative 30 meters? Well, the original question, he was at minimum was at 25, negative 25 meters. So it's actually impossible to have him being at negative 30 meters. So this question in itself is wrong. So these two questions in itself are wrong. So yes, you can get an answer, and this answer fits perfectly with the relationship. But in the situation of a word problem, you don't just consider what is mathematically possible. You also have to consider what is realistically possible. So if that's even a word, but anyway, so that's what I want you to get with these two questions. So then bad questions, not good questions, bad questions. They should not exist. But just to illustrate that word problems are different from just graphing because it has to be realistic as well. The answer must be realistic. So this one is realistic because when you talk about elevation, it can be negative. The graph shows that, it can be negative, but time cannot be negative. And that's essentially it.